This is Into Math 3rd grade, lesson 17.3. Solve problems about liquid volume and mass. I can solve word problems that involve liquid volume and mass. Please gather your workbook and a pencil and turn to page 447. We will start under Step It Out, question 1. Ava fills the 100-liter container to the mark shown to water a garden. She will use water from the 100-liter container to fill the empty pan on the right to the top mark. So we look over here and we see there is water in this container right here. And then we have another container that is empty. And we're noticing that there's some marks up and down both containers. So now we're going to look at the directions, part A, B, and C. Part A asks us to complete the bar model to show the amount of water in each container after Ava fills the pan. So what we want to do is we want to take a look first to see how much water is in this container right here. So we're going to have to look at these markings. We know that it's not 100 because 100 is up here and it is not filled to the top. When we look at the markings on here, we notice that the 20 is nice and big right here. And we notice there's also a 60 right here. So I'm going to look at that 20 and I'm going to look at the marks below that. There are 1, 2, 3 marks below that 20. So I would notice that this would be going up by 5s. 5, 10, 15, 20. Here's 20. So I'm going to keep counting by 5s on the marks. 25, 30, 35, 40, 45, 50, 55, 60. So here's where 60 is. Now I need to keep counting by 5s. 65, 70, 75, and that's where we stop because that's where the water level is. So we know that the total amount of water is 75 liters, and what we're going to do is take some of that water and pour it into the small container, which we know is going to fill to the top mark. What is that top mark? You'll see over here. That top mark goes to 25. So we're going to write in this small container, we're going to fill up the water to 25. Well, when we take 25 liters away from the 100-liter container, we're going to have something left, right? Because it's the same amount of water. We're just putting it in a different container and seeing what's left. So we can do this a couple different ways, but I think if we started right here and then we pour some water into this container, and how much water did we pour in? We poured in 25 liters. Then what we're going to do is we're going to just go backwards on this container 25 liters. So we're going to go by 5. So that would be 5, 10, 15, 20, 25. Here's where we would stop. And that would be at the 50 mark. So we can write in 50 liters because this water right here, we poured into this container and now there's 25 liters of water inside that container and there's only 50 left over. So now part B asks, what equation can you write to represent how much water will be in the 100-liter container? Well, first we started with 75 liters and we poured water into the other container. How much water did we pour in there? Oh, we poured in 25 liters. So we we subtracted 25 liters of water from 75 liters of water. And what did we get? What were we left with? We were left with 50 liters of water after we poured that. So our equation is 75 take away 25 equals 50. So we can answer part C. How many liters of water will be left in the 100-liter container? We know that there will be 50 liters. Let's turn to the next page, page 448, under Step It Out, Part 2. Pete ships a care package to his brother at camp. The mass of the soap bar is 58 fewer grams than the mass of a tube of toothpaste. What is the mass of the tube of toothpaste? Okay, so that's a lot of information. We have a picture showing the tube of toothpaste, the bar of soap, and our balance here. And so we're going to go step by step, A through D together. Part A asks, what information is unknown? What's unknown is the mass of the tube of toothpaste. Now let's take a look at Part B. Use the information in the problem to complete the bar model. So let's take a look at the pan balance and find out that here's our soap and here's the weight or mass of the soap. So we need to count those. If you'd like to pause and try this on your own and come back, you may do so, or just follow along with me. We have 20, 20, 20. So that's 20, 40, 60 plus 10. So that would be 70 plus 5. That would be 75. Then 76, 77, 78, 79. So the amount that the soap weighs is 79 grams. When we go back into the problem, we see that the mass of the soap bar is 58 grams fewer than the mass of the toothpaste. So we can write 58 grams here because we know it is 58 grams fewer than the tube of toothpaste that's right here. So now we can use the bar model to write an equation to solve the problem. So we show that the soap is 79 grams, and we know that it's 58 grams less than the toothpaste. So if we take 79 grams and we take 58 grams, we can put them together or add them, and we can find the total amount of mass for the toothpaste by putting those two numbers together. So you can pause and add 79 plus 58 and write the answer here. And when you come back, you will find that the answer is 137. So we can now answer Part D, which asks, what is the mass of the tube of toothpaste? And we can answer 137 grams. Let's turn to the next page, page 449, Part 3. Pete ships some markers to his brother at camp. Each marker has the mass shown. What is the mass of 6 markers? Okay, so this is one marker right here, and this is the mass of that one marker. So they would like us to, A, make a drawing to represent the problem. Well, I know that this is one marker, and we need to see how much that marker weighs. So we need to take a look and see how much each marker weighs. So let's take a look here. 5 grams plus 1, 2, 3, 4. So 5 plus 4 is 9 grams. So if I know that one marker is 9 grams, how many markers did Pete send to his brother? He sent 6 markers. So if you'd like to pause and try to draw something to represent the problem, you can do that and come back, or just follow along with me. I'm drawing 6 markers, and I'm going to write in the weight of each marker, and I know each marker is 9 grams. Now let's take a look at part B. Complete the bar model to represent the problem. If you would like to pause and try this part on your own, you may do so or follow along with me. I notice that the bar model is looking for the total of markers, and they have made what I did, they just put them all together. So they have 1, 2, 3, 4, 5, 6 boxes, and I know that that represents the 6 markers, and each marker is 9 grams. So I can write 9 in all of these boxes to represent each marker. Now I need to add or put all of the grams together, so I need to add 9 plus 9 plus 9 plus 9 plus 9 plus 9. And you may pause and do that if you like and come back and check. But when you add 9 6 times, you will find the answer is 54. So I will write 54 grams. Now there must be an easier way to do this. Let's look at part C. Write a multiplication equation to represent the problem. Well, I had 6 markers, so I'm going to write 6, and I know that each marker was 9 grams. So I can multiply 6 and 9 together, just like I represented here and here. And when I do that, when I multiply 6 times 9, I'm going to get the answer of 54. So I can answer the final question, what is the mass of 6 markers? I can write in that it is 54 grams. If you would like to go back and watch this video, you may do so and pause along the way as needed.